In 1994, it looks like the Hubble telescope captured an object depicting a beautiful city with snow-white towers floating in space. People called it heaven or celestial city, believing as if alien civilizations existed. We're excited and even speculated that the city was actually the center of our universe, but after careful examination, astronomers declared the image fake. Scientists later explained that the Hubble image captured was of the galaxy NGCC. Part of this image was cut out and photoshopped, and a celestial heaven was ready to trick the world. Even though there's nothing mysterious in the image, it has fueled widespread interest in the structure of our universe. So does the universe have a center, and how do we find out if it exists? Since ancient times, the sky dotted with the lights of stars has intrigued people, and they wanted to know if there was a center to this boundless cosmic canvas. Our ancestors associated it with something earthly and familiar, like flowers. Egyptians can sit in the sky as a lotus, and its core is the center of the universe, where gods dwell. Later, the ancient Greek philosopher Aristotle came to the conclusion that the planets and even the sun revolves around Earth. And in the 16th century, Nicholas Copernicus was convinced the Earth itself revolved around the sun, which was thought to be the center of the universe. In the 20th century, more advanced telescopes revealed how vast the cosmos is. At the beginning of the century, the American astronomer Hollow Shapley made a map of the Milky Way. According to it, the sun is just one of 100 billion stars was in the dark corner of our galaxy's spiral arm. And in 1929, the American astronomer Edwin Hubble proved there are thousands of galaxies in the universe. And that AUS isn't unique today. Our planet's cosmic address is very long. The solar system Orion, our Milky Way galaxy, local group Virgo cluster Lani, I-Care supercluster universe. This alone shows how complex and immeasurably diverse the structure of the universe is. Everything in the universe spins, from small asteroids to entire galaxies, but does the universe also spin? If it's possible to figure this out, we can calculate its center, a fixed point on a spinning object. Our planet's center of rotation is the axis connected to the north and south poles. For a basketball player spinning a ball on his finger, the center of rotation is the point of his finger contact with the ball. But it seems that the universe has no such point. All our observations show that unlike stars, planets, and galaxies, they don't rotate, which means it's impossible to find their centers in a conventional way. But maybe we can find them by mass. If an object has an end, it has to have a beginning, and its center would be a point that, on average, has the same mass in all directions. However, according to the standard model of cosmology, the universe is isotopic, it's the same everywhere. Of course, the mass of galaxies differs in some of their areas, but on average, it'll be the same in huge regions of the universe, millions of kilometers inside. Mass is like a cellular sponge, only an extremely large one, and it doesn't matter whether you're looking at this mega sponge from Earth or from the most distant exoplanet ever discovered, the picture won't change much. The problem of finding the center of mass in homogeneous space is impossible, nonetheless. Another component of the cosmological model, the expansion of the universe, may provide a clue. In 1929, Edgar Hubble measured the speed of galaxies located at different distances from our planet. Hubble noticed galaxies flying away in all different directions from Earth and were accelerating and speeding, and because of that, we can assume they all started moving from the same place. In ordinary life, finding the point of expansion of an object is easy. Screw a trash sheet to the ground, and then ask your friends to pull it from all sides. You'll notice that the point where the sheet is attached is the center of its expansion, but the same can apply to the universe. Since astronomers can see the expansion of galaxies from Earth, our planet should be a kind of center for the processes of our universe. Expansion works differently. Scientists have found that galaxies fly away when observed from any point in space, not just from Earth. The farther away from the observer, the more galaxies move away from them. So how does this work? According to the Edmund Hubble calculation called the Hubble constant, galaxies recede away from each other at the speed of 70.4 kilometers per second per megaparsec, or 3.26 million light-years at 1 billion light-years away. The expansion of the universe is carrying galaxies away from us at 22,000 kilometers per second, or about 7% of the speed of light. But at 100 million light-years away, this speed is only 2,200 kilometers per second. So when looking at galaxies from different places in the universe, hypothetical Civilizations would see galaxies moving away slower or faster depending on where they are, and because of that we cannot find a center of the universe in such a way, but couldn't we measure it from the point of the Big Bang? We believe the universe was born about 14 billion years ago. In the Big Bang, a massive cosmological explosion or expansion, we know that after any explosion, material expands from a specific point. It's sometimes possible to calculate such a point even with the naked eye. For example, if you take a picture of fireworks and look at the direction of light flying in the sky, it's easy to figure out where the fireworks burst out from.
Does this mean we can apply this method to the Big Bang?
The Big Bang happened everywhere in the universe all at once, and only then did matter begin to spread randomly throughout space. We know this because of the relic radiation that emerged after the bang. This is cosmic microwave radiation, which permeates space in all directions. Its approximate temperature is 2.7 Kelvin, but in some regions it can be colder in cosmic voids. The temperature of relic radiation is a fraction of a degree lower, but no deviation from the average temperature has been found in your regions of space, and if the Big Bang did have an epicenter, it would have been much hotter closer to the epicenter than elsewhere. Scientists compare the universe expanding after the Big Bang with a two-dimensional ball with points drawn on its surface that symbolize galaxies. If we inflate the ball from the inside, it'll grow in all directions equally, and it won't have a specific center. The dots on it will become evenly distant from each other. But the problem with this comparison is that the universe must have an end, but what if the universe is infinite? Scientists are finding more and more evidence for this idea, and if this is the case, they will never be able to determine the true size of the universe, and because of it, its center is accelerating faster and faster relative to the observer. At some point, the expansion must exceed the speed of light, and when this happens, we would find ourselves surrounded by an event horizon we wouldn't be able to look beyond. But what about the electric charge of the universe?
Would it help us to find a center?
Modern science tells us that the distribution of the charge of the universe is on average how much there are equal numbers of objects, with negative and positive charges in huge regions of space. And as a result the total electric charge of the universe is zero, so we won't be able to detect any special point in this way either. So far everything indicates the universe has no center, and of course it does not rotate. However, an international team of astronomers claim they might be able to pinpoint a center of our universe with the help of the so-called dark flow. Scientists made this hypothesis after studying galactic clusters from data collected by the Wilkinson microwave, a nice trophy probe. They noticed that about 1,400 galaxies between the Sales and Centaurus constellations behave abnormally, unlike others that traveled rather randomly. These cosmic objects move in the same direction, according to astrophysicists, whether they are galaxy clusters or gravitationally attracted by something with an extreme mass. This force drives the dark flow through the whole observable part of the universe and even beyond its limits. And it does so with an insane speed of not less than 600 kilometers per second, because monologists suggest that this flow gradually poles in more and more galactic clusters, and their point of attraction could be the center of the universe. Scientists believe that this could be a black hole, and if so, it's so huge that it has no analogues in the known universe. Perhaps the black hole is preparing for a new Big Bang. For this to happen, it would need to Poland and compress the older matter and energy of the universe into an indivisible single hilarity point. An interesting idea is that, through the center of this black hole, our universe could float directly into some parallel world. Which is in Harry Potter's. It seems more plausible to you to let us know where the comment is, and to make sure you don't miss out on anything mind-blowing happening in our universe. Stage India by subscribing. Thanks for watching.